Now, today's session will be dedicated to understanding the role of machine learning in data science. Okay. So, following the last few sessions, by now you might have understood, right, what data science includes. You might have understood that it covers a wide range of domains. So, of all that, machine learning is one of them. So today's session will be dedicated to machine learning. We'll try to cover at least regression today. Now, before we dig deeper into the machine learning part, let me just put the verbatim. There is this journal called Journal of Data Science. And just see how it states. It describes data science as almost everything that has something to do with data, be it data collection, be it analysis of data, modeling, and others, including all sorts of applications. Okay, all these things gets covered in data science. And of course, that will include machine learning, since we are including the application part as well. So machine learning comes into the picture. And of course, that way deep learning and artificial intelligence, they are also used in data science for analyzing data and extracting useful information from it. Let me...
Ma'am, one query.
Yes. Yes.
NLP is the part of machine learning or means deep learning?
It depends. Anyways, nowadays, so NLP has got its own dedicated section. Let me show you this screen. It will clear it. Let me show you this little diagram first.
Oh, okay, ma'am.
So I hope this is visible. So when we talk about NLP, AI, DL, data science, whatever, the umbrella term is your artificial intelligence, right? AI. This is the umbrella term. This is the main envelope that covers all. Within this AI comes your machine learning. Meaning machine learning becomes a subset of artificial intelligence. So it will include the set of algorithms and all those algorithms that gives your machines or your computers the ability to learn from data. It's a very famous definition, right? Machine learning provides your machines or your computers that ability to learn from data on its own. On its own meaning very negligible intervention from human side, right? Now again, the subset for this machine learning is your deep learning. Now where data science appears. Data science is here. Maybe you can draw data science here. So data science is that field that gets overlapped with all these AI, ML, DL. Apart from these, data science do cover, as we have already seen, mathematics, right? Statistics, maths and statistics will cover all. Mathematics, statistics, all other data visualization and whatever we have seen prior to this. here is your data science. When you talk about natural language processing, now natural language processing also, you can consider it to be here somewhere. Okay. And few experts do define NLP to be a separate domain. Okay. Different experts have different views here. So the picture looks like. Now, when I say this, that AI is the umbrella term, and ML ML will be the subset of it, is a subset of it. Can anybody describe what is the difference between AI and ML? Is this difference clear? Before we get into even further.
Here from this figure we can deduce that AI is the universal sets and ML is the subsets of AI.
That thing though, it can be deduced from this figure, but technically speaking, what might be the difference between this AI and ML? Right now though, we are focusing on ML, right? Today's session will be dedicated to this part, this ML part. But if somebody asks, what is the difference between AI and ML? How do we describe what is the difference between AI and ML? AI, ML, what is the difference?
Miss, in machine learning, whatever the data we feed, machine learns from those data only. But in AI, even the even the new data come, then AI learns from those data also. I think so.
No. In machine learning,
Yes.
we are trying to find the insights of data through statistics.
Okay.
With the use of statistics, but in case of AI, there is a possibilities of both, where we can find the insights of data through statistics, as well as some like what we are using in deep learning, which are like statistics, as well as like in a through using deep learning. Deep learning means
deep learning will again be a part of ML, right? When you speak of deep learning means you are speaking about ML, no? I was talking about this portion. This ML is subset of AI, right? That means there is not ML, is it? There is some AI which is not ML.
yes.
But all ML are, right? So I was asking what this blue portion represents. What is that AI which is not ML? In my
Ma'am, it represents.
Okay. Say.
Maybe.
Who is this?
I guess it represents the ability we give to computer by our code to stimulate in form of a human behavior without giving any data. Just like we write a code for tic-tac-toe. For machine learning, we need to feed the data so that it will predict a value. But then in AI and others, the other portion of AI, we can like stimulate it with a human, like how it can behave the same as a human behavior. Like for example, if we develop a code for tic-tac-toe, we develop that in artificial intelligence such that it for corner cases or
yes. Almost near. So that AI, which is not ML, are actually those systems which you can call the rule-based system, right? It won't learn from the data like ML does. ML is special in which sense? It learns from data, right? You feed data, learns from the data, tries to find out what is the pattern within the data. But there is one more statement, without much human intervention, right? Without the explicit coding, it automates the process, right? Without explicit coding, with negligible human intervention, right? Once it understands the data, so it can automate the process. Now, if I need to talk about difference between AI and ML, we need to talk about that AI which is not ML, means this blue portion. So this blue portion will actually be those systems that require some rule-based kind of algorithm, right? That might be working on some rule-based kind of algorithm. When I say rule-based, means you have to provide proper coding. Through proper coding, you have to specify that if this is input, you should generate this output. If input is A, you have to provide output as X. If input is B, you have to provide output as Y. Like the most popular example of AI, which is not ML, might be this, right? Chatbot, isn't it? It almost mimics the human. Of course, it does not carry human intelligence, but it almost mimics human process. But this is chatbot won't be considered ML as such, because we don't feed data to chatbot so that it learn on its own. It is not like that. We have to provide through coding the instructions, what he has to follow. So that makes AI different from ML. Of course, ML is a part of AI. So all those ML systems will be AI. But there are some systems which is not ML but are in AI, will be these systems. Is it clear? When we talk about ML means, we are talking about feeding data, making the model learn through data, making the model understand the pattern within the data, without explicitly telling it what to do, okay? But this portion of AI will require instruction, coding instructions from us human to provide the desired output, okay? I hope it's clear. Can I get a quick yes? Is it okay?
Yes.
So today we will try to cover, I have kept today's topic to be the role of machine learning in data science. When we talk about machine learning in data science, we talk about 3 particular machine learning algorithms. Those will be, one is the popular and the most used one, it is regression. First one would be regression. Next will be your classification, and then comes your clustering. Okay. So we'll try to cover these three. So when we talk of regression, classification, clustering, that means we are talking about supervised ML and unsupervised ML. Okay, regression and classification will come under supervised machine learning, clustering, unsupervised machine learning. When we say supervised machine learning, meaning we are talking about the condition when we have labeled data, right? Meaning, you know, input output pair. Yeah. For which input, what will be the output that is known to you. So when you talk about supervised machine learning, meaning you are talking about the conditions where you have labeled data. And you will use labeled data to train the model. When you talk about unsupervised machine learning, meaning you are talking about the case when you do not have labeled data with you. You don't know the output, the corresponding output. The only thing you know is the input data points. So first thing is this. Out of these three, again, when we talk about regression, we are actually talking about those techniques which are kind of, you might have heard of this term, which are kind of curve fitting techniques. When we say curved fitting technique means you have data points and the target is to find a curve that best fits those data points. So when I say regression means it includes both linear, non-linear. We have linear regression, we have non-linear regression as well. So first we will try to deal with the linear regression thing. Okay. Regression. Meaning suppose you have, as I said, regression means it is a kind of supervised machine learning. When I say supervised means you have labeled data, you have input output pairs. Okay. So this is X, this is Y. So when you scatter plot it, what do you get? You may end up getting a plot of this kind, right? So what linear regression does is, when I say linear regression means it tries to fit in a straight line that goes through these data points. Okay. And the target is to get this straight line, which is the best fit for the data available with you. When I say best fit, I mean to say the data points are at the minimum distance from this line of best fit. Okay. These, we can call these error terms, right? So linear regression or non-linear regression. Had it been non-linear regression, So you will have data with some curved pattern, right? So target would be to fit a curve of best fit through the data. So regression is this. When we say classification is again supervised machine learning, right? Meaning you have labeled data, you know input output pairs. But in classification, the target is to classify the data. You have to identify the data and give it a proper label. Like the most simple example would be, you have data, suppose image data you have, no? Cat and dog images. If you have a classification algorithm defined, the algorithm should be able to identify the cat and dog images from it, right? So that is classification. When you say clustering, now see clustering supervised machine learning. You only have the input data available with you. You don't know the level corresponding to those data. So what you do is, you just try to find out similar data points and group them, right? Something like this. You will try to find the groups, groups to which your data point belongs, meaning you will try to cluster them, hence clustering. So if
Sorry,
you wish
I am
to
interrupt in this meeting. It's less than 1 minute. Going to be close this meeting section because it is a 40 minutes on a slot. It's going to be off after 1 minute. Then again, I just log into the Zoom meetings links. Same links, please join all to continue this training sessions. Okay.
yes.
Yes, madam. Madam, can I stop this meeting right now? Can I end this meeting session right now?
Yes, sir. Yes.
Thank you, madam. I just log in after.